This is also a very simple question. Yeah, so you've been given this, and this is the x-axis, and the y-axis is supposed to be somewhere there in between. All right, so we first have to draw a, okay, so I didn't see that there is also another force here. We have a force along the x-axis here, which is 8 newtons. So we don't have to forget that as well. So the most important thing to know is that you have to find the summation of all forces in the x, you write it. You also find the summation of all forces in the y, you also write it. So let us start with the x. So in the x, okay, let me write it somewhere here so that at least. So we first find summation of forces in the x. So in the x, we have these 8 newtons. It's only in the x, it doesn't have the y component. So in the x, we have 8 newtons. And then we also have this one here, this 100, the x component of 100 is also along the x-axis there. So what you just do is, since it's pointing towards the positive, so we say positive, and then we write 100. This is the short form of what I was explaining, because there are a lot here. If I start writing everything, we will not manage to write all the things here on the screen. So you have 100, and since it's the adjacent, the x component of this force is the adjacent to 45. So you just say 100 what? Cos the angle that you've been given there, which is 45 degrees. Then you also move on to the next force. The next force, the x component of this force is adjacent to the angle. So meaning we're going to use cos, and it's pointing towards the negative. So we say negative, and since it's adjacent to the angle, we say 110, 110 cos 30. The other force that we have is this one. The x component of the 160 Newton force is also along this same axis, and it's pointing towards the negative, and it's going to be a negative there, and it's adjacent to the angle, meaning we're going to say 160 cos 20. So we find the final answer there. So we're going to say 100 cos 45, that is giving us 70.7. So the summation of forces in the x is going to be equal to, so we have 80, we have positive 70.7, and then we have negative, so we have 110 cos 30, 110 cos 30, that is 95.3. And then we also have the other one, which is 160 cos 20, 160 cos 20, which is a 150.4. So we have to add all that. So we have 80 then plus 70.7 minus 95.3, then minus 150.4. Okay, I've made a mistake. Let me. So I'm saying 80 plus 70.7 minus 95.3 minus 150.4. Okay, this has given me negative 95 newtons. So we also do the same. We find the summation of forces in the y. The summation of forces in the y, we'll also start with this one. So the force in the Y for 100 newtons. So the force in the Y for 100. So for this one, for 80 newtons, we don't have any force in the Y, so we leave that. So we move on to this one. Or if you want, you can just write a 0 to show that you know what you're doing. Then we say positive, the force in the Y for this 100 Newton force is pointing towards the Y. So, I mean, towards the positive Y. So it's going to be positive there. And then since it's opposite, meaning we're going to use sine from Scalar. So we're going to use sine since it's positive Y and it's opposite to the angle. So we're going to use sine. We're going to say 100 sine 45. And then we have this one. This one is pointing towards the positive. So it's also opposite. So we're using sine. We're going to say 110, positive 110 sine 30. And then we also have this other force, which is also pointing, oh, sorry, this one is pointing down, not up. This one is pointing down because we have to go this side and then go down. So it's pointing down. So we have negative 160. It's also opposite to 20. So we use sine 20. So we can find the summation of forces in the Y. So we have 100 sine 45. 100 sine 45 gives us 70.7. And then 110 sine 30. 110 sine 30 gives us 55. So we have plus 55. Then we say minus 160 sine 20 gives us 54.7. So 54.7. So it's just a matter of adding up the angles. So we have 70.7 plus 55 minus 54.7. This gives us 70.97, which is just the same as 71. So we have 71 newtons. So now to find the resultant, the force, the F resultant is just equal to the square root of all the forces in the x squared. So we say summation of forces in the x squared plus summation of forces in the y squared. And the resultant force will therefore be, so we're squaring negative 95 and also 71. So the resultant vector here, or the resultant force, is therefore going to be the square root of, so 95 squared. So when you square that, we're getting 140627. So we're getting 1406.2.7. Then when you square that to find the square root of that to get the resultant, you're getting the answer as 118.6. So we have 118.6 newtons as the solution. So it's as simple as that. Quickly move on to the next question. Determine the value of the resultant force. So do we have to do this one, or it's similar to the previous one?
I think time is running out. Maybe we can end here. Or maybe just quickly run us through the determination of a known vector. We can use one example.
Okay. So let's use this same first example here. So here you've been asked, and by the way, I'm sure you can find the what is the direction. Huh? If, let's say for instance, on this same question, if they ask you to find the direction of the resultant force. So this is the resultant force. the direction is simply just the angle. The direction is found by theta is equal to tan inverse of what? Of f in the y over f in the x. So to find the direction of this, you simply just divide the force in the y divided by the force in the x, and then you find tan inverse of that, and that is the direction. It's simply just the angle. Okay, so let's quickly do this one. So they're asking us to determine the vector k in the figure below, given the resultant value as 30, as 50. What they're talking about and the question here is a bit different, because they're asking us to find k, and they're asking us to find the vector k in the figure. They have not even shown which k, where k is, given that the resultant is 50 and there is 30 there. Okay, we assume that we've not been given the resultant there, or maybe I take another example if there's one which is, oh, sorry. Okay, let's do this. Okay, they want us to find the other component, in short. So we've been given one component of this vector, which is 30. We've been given 30 and the resultant has been given to be 50. Then we're trying to find the other component here, which is the other component, which is the y component of the vector 50. So this one is straightforward. You also use, so if you want, you can first use SOHCAHTOA to find the angle. And then after using SOHCAHTOA to find the angle, you then find the other component using SOHCAHTOA again. Or if you want, you simply just use the Pythagoras theorem. That's all. So we have the 90 degrees there. So the Pythagoras theorem states that so this one is the opposite. If we're taking this as our angle theta, this one is going to be the opposite. So we know to say the hypotenuse squared is equal to the adjacent squared plus the opposite squared. So the hypotenuse has been given to be 50. So we just say 50 squared is equal to, the adjacent is what? Is 30. We say squared, and then plus the opposite, which we're looking for, squared. So you just take the 30 squared on the other side. So we have the opposite squared is equal to 50 squared minus 30 squared. So the opposite squared is therefore going to be equal to 50 squared minus 30 squared, that is 900, which is 1,600. So the opposite is going to be the square root of what? 1,600. So the opposite is therefore what? 40 newtons. So this side is 40 newtons. So you simply just use the Pythagoras, 40 newtons. So this one, you also do the same. You've been given the hypotenuse. You've been given the hypotenuse and and this other one. We don't know if the angle is there, but if we take it as the angle is there, means that this one is going to be the adjacent. So you also just use the Pythagoras theorem. You use that. So this is going to be, we're trying to look for the adjacent squared. So the adjacent is going to be 65, because we know to say the Pythagoras states that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So you just take the opposite squared on the other side. So you're going to have 65 squared minus, so what we're trying to look for is actually the opposite, not the adjacent, because the adjacent has been given there. So we're trying to look for the opposite again in this question. So the opposite squared is equal to the hypotenuse squared minus the adjacent squared. So the opposite is what? 65. Oh, sorry. The opposite is the one that we're looking for. So we have the opposite squared is equal to the hypotenuse is 65 squared minus the adjacent is 28 squared. So the opposite is going to be the square root of what? 65 squared minus 28 squared, which is the square root of 3441. So the opposite is going to be the square root of that, which is 58.6. So 58.67 newtons. So that is going to be your angle there. But because it's facing towards this side, towards the negative, meaning it has to be negative. Okay, so if you don't want to use this method, let me show you another simple method you can use to get the same answer using SOHCAHTOA. So for SOHCAHTOA, you first have to find the angle. So you've been given the hypotenuse and the adjacent. So let us find the theta there. So you've been given the hypotenuse and the adjacent. Hypotenuse and adjacent is on cos there. So we say cos theta is equal to the adjacent, which is 28 over the hypotenuse 65. So our theta is going to be the cos inverse of 28 over 65. So this is going to be so 28 divided by 65 is going to give us that. Then cos inverse of that, the answer is 64.4. So we're going to get 64.5 actually degrees as the angle. So having been given the angle there, so we found the value of this angle, which is 64.5. We found the angle there, 64.5. So after finding the angle, it's now easier for us to find this using again SOHCAHTOA there. So we've been given the hypotenuse there. We've been given the hypotenuse and the angle there. So hypotenuse and the angle, we have the hypotenuse and trying to look for the opposite, which is opposite to the angle. So we're using sine. So we're going to say sine 64.5. Sine 64.5 is equal to the opposite over the hypotenuse. So the opposite is what? Is the one that we're trying to look for. And then over the hypotenuse is 65 newtons. So when we cross multiply there, the opposite will therefore be equal to. So we're going to have sine that. We're multiplying it with what? 65. And this gives us what? 58.66. Actually, this one isn't supposed to be 7, it was also supposed to be 6. Because after 6 there is a 0. Okay. So that is what you are going to get. So you can see that you've gotten the same answer. So you can either use SOHCAHTOA or just the Pythagoras theorem. You get the answer. Okay. So do we also have to go through this?
I don't know about Natasha, but I think I'm running out of time myself.
Also, all right. So we're going to find some time to come and discuss this. Natasha, do you want us to go through this or? You're debating.
Edward, we can go through it. How long will it take?
No, it depends on you guys, what time you're having the test, and if you still have time, if you need time for you to go through them to revise.
I think I'm okay. We can go through this.
Okay. Okay, so this is the question there. And Okay, I don't know the question here. I don't know because they've just given us this object. Oh, the question is determine the value of the weight of the object in the figure below.
Mhm.
So we've been given that in this cable here, the tension is what? Is 30 newtons. Then the
30
tension for this cable has not been given. And we've been asked to find the force in the code 1. Yeah, because they're asking us to find the weight of this. So the weight of this is equal to the force or the tension that is in the code 1 here. So this is also a simple question. How do we go about it? Let us quickly see. So this one, the way you solve this question, okay, you first have to draw a free body diagram, just showing these codes there. So I'm going to draw it here. Then we have something like this. So we have 30 newtons this side. Then we have the weight, which is the one that we are looking for, FW. And then there's also this, which has to be resolved in two components. So we have code 1, so I'll call it C1, and then this one is C2. So here, we just have to find the summation of forces in the X and Y. That's the simplest way to do that. So we first find summation of forces in the X. We know that summation of forces in the X, when you talk about equilibrium of a particle, is always supposed to add up to 0. So summation of forces in the X is supposed to add up to 0, and summation of forces in the Y is also supposed to add up to 0. So in the X, we have 30 newtons pointing towards the positive X. So we first find summation of forces in the X is we have 30 newtons there, which is pointing towards the positive X. So I'm going to write positive 30. And then for code 1, which is C1, we don't have any component in the X for this code. Yeah, so we skip it, we move on to this other code. So code 2 has the component in the X. Yeah, it has the component in the X. The angle that has been given here is 50. So the X component of this code is this part here. Because I know that if I'm moving from this point going this side, I have to first go like that and go like that to the negative X. So since I'm going to be going to the negative X, I'll put my negative there. And then the angle here is 50. So if the angle there is 50, meaning this is going to be my what? The X component is going to be my opposite. So if we're using opposite according to Sokatoa, opposite and hypotenuse, which is code 2, opposite and hypotenuse, we are using sine. So we say minus. So I'll call this C1 sine what? C1 sine 50. So this is the summation of forces in the X. We don't have another force. So we say this is equal to what? 0. So we have 30 minus C1 sine 50. Then we say this is equal to 0. So we can make C1 the subject of the formula. So C1 is therefore equal to 30 over sine 50. So C1, meaning the tension in the code, oh, sorry, not C1, it's C2 here. It's supposed to be C2 because this is 2 there. I thought that was our C1. So this is C2. So C2 is therefore going to be equal to 30 divided by 30 divided by sine 50. And this is going to be 39.2. So it's giving us 39.2. So C2 is 39.2. So let us also find the summation of forces in the Y. So summation of forces in the Y summation of forces in the y, this one is only in the x. We don't have a y component of this code. So we find the y component of code 1. So code 1, the y component is pointing towards the negative y. So we say negative C1. And then in the y for this one, the y component of code 2 here is simply just this side there. That is the y component of code 2. So the y component of code 2, the y component of code 2 is simply just this side. Okay, so this is so the y component of code 2 is this side, and this is adjacent to 50. So since it's adjacent, we use cos, because cos is the one that deals with the adjacent and the hypotenuse. So the adjacent there, positive 1. So we say positive C1. Oh, sorry, C2. This one is C2. So we say positive C2. So our hypotenuse is C2. So positive C2, and we're using cos. So we say cos 50. Cos 50 degrees. Okay. So, and we said all these forces, if we're dealing with the equilibrium of forces, they're supposed to add up to what? 0. So we say this is equal to what? 0. So we take this to the other side of the equal sign so that we find C1. So C1 is equal to, so we have negative C1 is equal to negative C2 cos 50. So C2 has been found. We found C2. So C1, if we divide by negative on both sides, C1 will be, C2 was found to be 39.2. So we write 39.2 there. Then we say cos 50. Oh, sorry for that. So cos 50. So my C1 is therefore going to be equal to cos 50 times 39.2. And this is giving me 25.2. So my C1 is 25.2 newtons. So the weight of this object is simply just 25.2 newtons. Okay. So we move on to the other parts of the questions. So all these questions are simple. Actually, this is the last question.
Okay.
Yeah, so even this one is simple. Yeah, so this one, the way we solve it is a similar way we solved the previous question. So what you just need to do is to, what you just need to do is to just know how to find the components, that's all. So we also find the summation of forces in the x. We know that for equilibrium of particles, this is supposed to add up to 0. And also summation of forces in the y is supposed to add up to 0. So we start with summation of forces in the x. This is going to be equal to, so in the x, we have negative, or we start with T1. So for T1, the x component of T1, since the angle is there, we have a Z angle there. So we have this one and that one. So we can get that as our 60 degrees as well. So this angle here is 60. So we have 60 there. So the adjacent to 60 degrees, I mean, the x component of T1 is the adjacent to 60. So this is going to be T1. Since it's adjacent using SOHCAHTOA, we're going to use cos 60. And then in the x, this, T2 in the x, it's moving towards the negative. It only has the negative x component, it doesn't have the y. So the x there we say negative T2. And we say this is adding up to 0. So T1 cos 60 is equal to, when you take T2 to the outside, is equal to T2. So let us also find summation of forces in the y. So the summation of forces in the y, we have the component of T1 in the y. So the opposite there, since the opposite side of 60 is the y component there, and this implies that this is opposite, meaning we're using sign. So we're going to say T1 sine 60 degrees. And then in the y for T2, we don't have any component, any y component for T2 in the y. So we leave that. Then the y component for T3, which is equivalent to the weight there, is what? Okay, it's T3 is only in the y. So we simply just write our T3 there. So it's simply just say minus, I'm saying minus T3 because it's pointing towards the negative y. So according to the question here, they are saying what are the tensions in each rope, assuming that the weights of the ropes and the knot are negligible. If the weight of the block is 100 newtons, what is the tension in the ceiling rope? So the weight of what? Of the rope of the block is what? 100 newtons. So this one here is 100 newtons. So if this is 100 newtons, we take it as T3 is also what? 100. So what is T3 there? I'll put 100. So if this T3 goes to the other side of the equal sign, we're going to have T1 sine 60 is equal to what? T3. So my T3 is what? Is 100. We've been told to say this is 100 newtons. So I'm going to put 100 newtons there. So to find T1, so T1 is just going to be equal to 100 divided by sine 60. So we say 100 divided by sine 60, and this is giving 115.5. So T1 has been found to be 115.5 newtons. That is my T1. And then we also find T2. So T2 is simply just T1 cos 60. So T2 is simply just T1 cos 60. So T2 becomes T1, which were found as 115.5, and then we say cos 60. So cos 60 is 0.5. So we just say 0.5 times 115. This is given 57.7. So our T2 is therefore going to be 57.7 newtons. So this is what we have as our T2. So now the other part which is remaining, which other one? I think we have managed to find all the ropes. Yeah, we've managed to find all the ropes, which is T2 and T1. So our T1 is 115.5, our T2 is 57.7 newtons. All right, Natasha, thank you very much for attending tonight's, today's lesson. So I'm going to send the recorded sessions to the group so that you can have a look, or rather you can revise in case you want to revise any questions. And don't forget to tell your friends about this program. Say, I'm going to be helping in mathematics and physics, and it's only 100 kwacha per month for each course. Yeah, so if you're taking both math and physics, it's 200 kwacha per month. All right, so thank you very much. See you in the next lesson. I'll send the updated timetable for both physics and mathematics, so that at least we should know the time we'll be meeting for physics and the time we'll be meeting for mathematics. All right, see you in the next session.
All right, thank you.
You're welcome.